Hello everyone, today's notes are the Pythagorean Theorem. This should just be review for all of us. So for the first thing for Pythagorean Theorem, we use Pythagorean Theorem when we have a right triangle. If we do not have a right triangle, we are not allowed to use the Pythagorean Theorem. So you know you have a right triangle when you have that little half of a square in that bottom corner, and any of the corners actually, then you know it's a 90-degree angle. So when we have our sides, we look at our sides A and B here. These are called the legs of the triangle. And then you have your side C, which is always directly across from the 90-degree angle. This is going to be your hypotenuse. Okay, and then again, that's always directly across from the 90-degree angle. The Pythagorean theorem is used to find a missing side length. And again, I said it has to be on a right triangle. And then the formula, you guys probably remember, this is the a squared plus b squared equals our c squared. So the legs squared added to each other equals the hypotenuse squared. So we're going to kind of see if we actually have right triangles here first. So we're going to test 8, 15, and 17. So always the lower two numbers are going to be the legs. So we have 8 squared plus 15 squared equals 17 squared, meaning that the highest number out of those three will always be the hypotenuse. So when we do 8 squared, we get 64, which is 8 times 8. 15 times 15, we get 225. And 17 times 17, we get 289. So we now just have to add 225 and 64. When we add those two, we get 289, and we see that our left side of our equation now equals the right side of our equation. So since they actually equal each other, then this means that we do have a right triangle. So let's go ahead and test out our next one. Again, these are our two lower numbers, so we're going to put those on the left side of our equation because those represent the legs. And then the higher number, that 12, is always going to be the hypotenuse, the larger number. So now we're going to do 5 times 5, which is 25, 9 times 9, which is 81, and 12 times 12, which is 144. We're going to go ahead and combine 25 and 81. We end up getting 106, which does not equal 144. So these three values are not a right triangle. So we would not be able to use the Pythagorean theorem for these three numbers. Alright, so let's go ahead and actually look at how we would use the Pythagorean theorem. We're going to be finding a missing side here. We see that the x is on one of the sides. So we need to identify which values we have. These are, this x is directly across from the 90-degree angle. So that means that that is our hypotenuse. So I'm just going to write x squared as my hypotenuse. And then we're going to use these two values as our legs. It doesn't matter which one is A or B, we're just going to do 15 squared and 18 squared. Once we do the 15 squared, 15 times 15, we're just going to go through and solve just like we did on those previous examples where we were testing to see if it was a right triangle. Okay, so I'm going to add 225 and 325. I end up getting 549. That equals x squared. In order to get rid of that square, so the reason why we've been working with radicals is because, again, that radical is the opposite, the inverse operation of the squared. So we have to square root both sides. This is x equals, and then we actually are going to simplify the square root of 549. We are going to leave our answer in simplified radical form. So first of all, I'm going to break this down. I'm going to divide it by 3 first because I don't, I want to make sure that 3 goes into it first. I don't know the highest value. So this is 183. I believe 3 goes into the 183 as well. So this, yes, I am correct. 3 is 61. So we're looking for pairs because we have a square root. So that means I have 3 square root of 61. We cannot break down that 61 any further. So we're going to leave this one in simplest radical form. I'm going to show you guys leaving it in decimal form as well. So if you were to actually take the square root of your 549, you would end up getting 23.4. And we're going to talk about feet here, and this would also be feet. So make sure the reason I'm getting feet are they're right here. So this is your decimal form, and then this would be your radical form. Let's go ahead and do another example. So on this example, we're still identifying a side. The x is on the outside here. However, our hypotenuse is actually 11 centimeters. So we're going to say 11 squared on the right side of our equation. Then we're going to plug in the 3 squared plus x squared. I'm going to go ahead and simplify what I can, which is just the 3 times 3 and the 11 times 11. Now we have to actually solve for x by subtracting 9 from both sides. We're trying to get it by itself. And I get 121 minus 9, which is 112. Again, taking the inverse operation of the squared is taking the square root. Those divide out. And if we leave this in simplified radical form, I'm going to divide that by 2, which we know is 56. 2 times 2 is 50, or sorry, 2 times 56 is 112. And then if I divide that into 8 and 7, and then we have 4 and 2, and I'm going to leave this one actually here because I know that the square root of 4 is 2. So I have one pair of 2's coming out front, another pair of 2's coming out front, and this 7 staying inside. So my final solution and simplified solution here is x 4 square root 7. Remember, I had 2 groups of 2's coming out front because the square root of 4 is 2, and there was another 2 groups of 2's as well up here. So 4 square root 7 is my simplest radical form, and we were in centimeters. And then if I were to get a decimal for that, we would just take the square root of 112 and put that in our calculator, and I would get 10.6 centimeters. So again, be sure you guys are using your units, and either way, decimal form or simplest radical form, I will let you guys know which form on whatever worksheet or test I'm giving you. So now we just want to find the length. We're going to be talking about word problems here. We want to find the length of the rectangle that has a diagonal of 25 feet and a width of 15 feet. So I suggest on every word problem that you draw a picture. So I'm going to draw a rectangle, and then the length of that rectangle actually has a diagonal. So your diagonal goes from one end to the other, and that length of the diagonal is 25 feet. Okay. So we have our 25 feet, and then a width of 15 feet. So I always say length times width, which means this would be my width. It actually doesn't matter which one, but this is going to be my 15 feet here. So what we want to do is we actually only want to look at one triangle because we see that this rectangle got split into an actual 2 triangles, so we're going to work with one of them. And I just happen to be placing the values on this bottom one, so that's the one I'm going to work with. Your 90-degree angle, a rectangle has, these are all actually 90-degree angles in every corner here. So our 90-degree angle, I'm going to redraw this picture so that you guys can see what I'm actually working with here. And this is my 90-degree angle, this is still my 15 feet, and this is my 25 feet. And this is the side that I do not know. You could put it as L for length, or you could put it as X. So what we're going to write here, this directly across from my 90-degree angle is my hypotenuse, so that's going to go onto the right side of my equation. And then I have x squared plus 15 squared, and we're going to go ahead and simplify what we can. 15 times 15 is that 225. Equals, and then 25 times 25 is 625. We're going to subtract 225 from both sides, getting that x by itself. So now I have x squared equals, and we should be getting the 400. So now I'm going to take the square root of both sides. I have the square root of 400 actually comes out to be a nice value of 20. So we were in feet, so I have 20 feet, and that is the length of my triangle. Since we have a word problem, we are going to write a complete sentence stating what the actual length of this triangle is, or rectangle, sorry, the length of the rectangle is 20 feet. Alright, so that's our final answer here. And we're going to do one more word problem. So again, draw pictures. Ivan rides his bike 9 miles south, then 12 miles east. How far is he from his starting point? So we are going to say that this is Ivan, my little stick figure drawing. Okay, so if he is riding his bike 9 miles south, so he's going to go south. South, remember your little compass here, north, east, south, west. Okay, so he went south, and that was 9 miles. And then he went 12 miles east, so that's going to the right. So this is 12 miles. And then we want to know how far he is from the starting point. So all of a sudden he went down and then to the right, so now he's here. But he did start here, so we want to know this distance from here. This is our question mark, that x. So we have our triangle. This is our 90-degree angle here. Directly across from it is our hypotenuse. That x is going to go in the hypotenuse section, and we are going to set up the 9 squared and the 12 squared as our legs. So now 9 times 9 is 81, plus the 12 times 12 is 144, and we still have x squared that we are unable to simplify. Then we are going to add the 81 to 144. You take your x squared, you're going to square root this in order to cancel out the squared and square roots. Square root of 225 is 15, and that is our x value. So our what we just figured out again, Ivan is 15, make sure you're putting those units, miles, from the starting point. And this is all for our notes today, if I could write point. And we will go over some of this in class, so I will see you guys in class. Thanks.